Hey everyone, this is Eugene and Matt, and today we're gonna review artificial coin contract that was implemented. And this contract is attempts to implement a stable coin on Near. So let's jump into
I thought it was a coin for artificial intelligence.
they're the same, like stable coin, artificial intelligence. So the README basically saying it is two contracts. One of them is art coin for governance, and another one is actual ArtUSD token. So art token, a governance token. It allows to be locked. Um, so you can stake and mint in order to mint AUSD. So you need to stake 5 times the amount you want to mint, and also it provides rewards based on inflation rate, and they staked, so you get in more governance token, but AUSD becomes like remains stable. Now AUSD token is just a token and you can transfer it, but then you have an option to burn it to on stake, um, which is required by art token to redeem the art token. And basically it's saying stability is guaranteed by mint, deposit, burn, and stake semantic. So you either can always swap at the rate where the owner comes in. So I'm not sure how the multi-stake, and then they say owner is centralized, but then it's going to be multi-signature account of all art holders, but that's unclear how fast they can react to the actions. So you must have a zero deposit, otherwise you can just burn to and stake. So, and then there's an oracle that pretty much fits the price right now. Matt, do you
Yeah.
have basic understanding of what's going on?
Yeah. I'm not a DeFi expert by any means, but it's pretty easy to follow, like the mechanisms.
So what I'm missing is why 20% here are important. If we can go one direction, another direction, right? So you can take AUSD to get art token. No, you cannot do this. You can only return your stake token if you have AUSD. Like you can unstake. So let's say AUSD or like art token falls in price. Um, how you guarantee the stability of AUSD price? Is this the swap that is provided by the contract?
I think I mean, what they're going for is they're going for, it's an over collateralization rate, right? Like,
Oh, you stake
so
near, right? You stake near, not art token. So why do you need art token? Or like how you get a art token in the first place? Near an art price oracle. So like it's not fully clear. Like, okay, so let's say you have this art token that is inflating faster potentially.
it inflates according to the near same schedule as near.
Yeah, just this here, for example, it's saying that it's does inflate faster. There's always some collateral grab, right? So how you grab the collateral in, like, it's not explained here. What's backing art price? This is also not clear to me. So once a user wants to unstake the art token, so it's unclear like why. Okay, yeah, I'm missing something. So let's start with art token, and this is near SDK, some fresh. Okay, so there's inflation hard coded here. Then we have an account that has the balance, allowances, staked, and assets. I guess that's the old fungible token before the new fungible token was invented. Then we have the contract interface towards calling AUSD. So you have mint, burn to unstake, burn to buy asset, buy AUSD, sell AUSD. Okay. Yeah, so here you want to have capital U potentially. And this is the main contract. So it has a list of accounts, total supply of art token, price in USD. Okay. The owner, a USD token ID, total staked, asset prices, reward. Somehow it's U64. Okay. And when the stake, okay, it's timestamp. And when the staking rewards are enabled. Okay, default, init, ignore state. Oh yeah, kinda. Guess it's just for testing, but it does override the state. No. Probably you wanna remove this part. Otherwise it's not super secure and will cause conflicts anyway. Okay, So we parse total supply. Then initiate, and then we provide entire total supply to the owner ID and save it. Now the method to refresh rewards. Okay. So we get the signer ID. So here we want to do predecessor instead of signer, because signer is not secure. Stake balance. Yeah, that's a bit weird. It's like can be improved using this U, capital U everywhere. So you don't need to parse it manually like this. Okay, get an account. So if the amount staked for this account is 0, we don't need to do anything. Otherwise, we check when the reward was paid. Otherwise, the moment when they were enabled for this account. Now is a timestamp, new staked, days, how many days passed from now to the moment. Okay, if 0 days, then otherwise we switch to years. Days, or, well, that's kind of shaky in terms of days, because 1 month is 30 days. Okay, oh, I see. Okay, it's just how it's done in a month. Okay, new state equals r to integer, so we multiply by ratio, and to integer, I guess, convert it to u64, then we decrease, 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 new state 1. Okay, that's cool. Does ratio handle overflows? Not sure. Okay, so we computed how much the new stake balance is. So we say, okay, stake balance was that. Now the new stake balance is this. Why it's a stake balance, I'm not quite sure, because I think README said that the rewards will be unstaked, but they actually restaked. Increase total supply by the difference, increase total stake by the difference, and we save the account. Get account, get stake balance. Yeah, that's a bit weird path to do this. Okay, and then we saved when the rewards were paid at by the number of days. and we just minted more stake balance for this given account. Cool. Okay, a method to buy art with near. So this is, I guess, how you link price of art. So this is how you get it in the first place. And you get the account ID. Again, you want to use predecessor here. You get the price, asset price of A near. On Rapa default, it will be 0. So if no price, then we cannot buy. We get the price of art. Okay, in dollars. So you, again, now how much you get is near price divided by art price multiplied by the near. Well, we only can hope that the ratio doesn't handles overflow, okay? Because it's unclear which ratio we use. Is it big integer or not big integer? I feel like it's not big integer, it's U128. Then what is this price in what it denominated? It's like price of one near in USD or one yokta near. Okay. But yeah, I feel like there might be some overflow on ratio, but I guess it may be tested. Or maybe it does mass in like higher big integer and then converts it to integer. I don't know. Matt, have you worked with ratio? Anyway, so we get the owner and we say the account balance we increase and the owner's balance we decrease. And save both owner and account. An owner has all the art. Okay. What we need to look here is we don't really track the attached deposit. So if you sell art for near, then and there's a price fluctuation, you can potentially run out of buyer or like owner's balance of near, but I guess we don't have it. Okay, so you can exchange art to AUSD. So you say how much you want to do, and then unit price AUSD by amount by denominator, so there's some fee, then account ID, again predecessor. We usually also do like one yoctanier on such operations because you don't want to this being called without explicit approval by the account. Okay, owner balance, we decreased by amount, on account balance, owner increased by amount, then save both of them, and then we issue by AUSD for the AUSD amount of the tokens and give half of the gas. So this is not very secure because if I don't attach enough gas, this will run out of gas and kind of not get the tokens. So the best way is to actually specify the amount of gas you want to do. Exchange AUSD to ART. So this is inverse. So you say AUSD amount, again, which calculate how much you should get. And we immediately credit you. Well, that's kind of scam. Because what if you don't have that amount? So it should be reverse. You call it first, then it calls you back. Or you kind of call this, then have a callback. Then you do unwrapping here. Buy AUSD with near. So that's somewhat similar. We just took your money and minted new AUSD at a given price. Interestingly, there is no commission to do this. Sell art for near, this still not implemented. So you cannot sell it. Now set allowance. This is common, submit price. So we verify that predecessor is not the owner. Oh, actually, is the owner, and then we set the price of AUSD, and we can submit the asset price as well by the owner. Now stake and mint. You say how much you want to stake. So we call stake, then we divide by 5 at the unit price. And that's how much we mint of AUSD. Stake is, takes the stake, refresh and rewards. Again, you want to use predecessor here. Get in the account ID. And we decrease this amount by the staked amount, and we increase the amount by new balance, increase this total staked. And we say that you paid all rewards at a given timestamp. I mean, that's probably not needed because this one will save it as well. And okay, you may need it because you increased your stake, right? Okay, save the account and return the amount. But you already saved the account, so you don't really need to save this again because it was saved in the past. Okay, unstake. So we verified that it's called by the AUSD token. Then unstake amount is 0. Panic, refresh rewards. So refresh rewards is a problem because it's called by AUSD, not, I guess you used a signer account ID, and that's why it worked. But what you want to do, you want to instead pass account ID from AUSD. So relying on a signer account ID is problematic because there can be a middleman contract that will initiate an action on you on your behalf, and that will pretend to be your account while it's not your account coming from your account. So the middleman contract, like let's say you called some contract like draw pixel, but it actually like called this contract, and because the signer is still you, it will act like you called it directly. That's why we
So it's
always.
like Eugene, it's like any contract deployed after this contract is deployed, right? So this contract's deployed, I go to it, I get AUSD, and then I go to any contract deployed after, could be malicious, and then could do a cross contract call to this contract. But this contract is going to think I'm the signer, but really it's the other contract that is cross contract calling it that is the predecessor.
Yeah, exactly. Yeah, so that's why we always rely on the predecessor, and then if you need to like call it from other contract you just that you trust, in this case you trust this contract, so you just pass this actual predecessor, like we do like a sender account ID as an argument, and then you can use it to pass to refresh rewards, I guess. Okay, so you get the account ID, staked balance. If it's less, then you cannot unstake, then otherwise you unstake. Increase the balance, decrease the total staked. And save the account. Right, transfer from. So this is part of the standard token transfer, total supply, get total balance. And stake balance. Total balance is balance plus stake balance, and allowance, stake balance, price, asset price, asset balance, and rewards paid at. Okay. Yeah, overall, the biggest problems are um, this reliance on signer instead of predecessor. And again, here you can just mint ton of where is it? In buy in sell AUSD to art, right? So you just increased your balance by the amount without charging anyone. So you charge it here, but this one can fail potentially, either because not enough gas is attached or because um, of the, well, you don't care what this method returns, because this one will not be rolled back. So this will execute, you got the tokens on your balance, and now you can do whatever you want with these tokens. So the state of the AUSD is invalid. The correct way of doing this is calling sell AUSD, waiting for confirmation that it succeeded, and then only after this credit the account. All right, so let's look at the AUSD contract. So again, all fungible token, 2 callback methods. So you have a list of accounts, our token and owner ID. So it's pretty much a standard NFT 21, which is deprecated with the with the extra methods to like mint. Okay, so this is all standard. Okay, mint. So we verified that this is called by art token, which is good. Now we rely on the signer account ID, but we should rely on the predecessor. That is signer, that is passed here. So it should, mint should take the account ID on which to act. We increase the balance, increase total supply, and save the account. Burn is acting similarly. We decrease the supply and save this. Burn to unstake, so we burn to unstake and then call unstake. Well, that's not gonna work because of the it has to be called by, so predecessor has to be art token. So you need to decouple this piece that verifies the predecessor and that one that calls it. Burn to buy asset, again, similarly. That's pretty much cannot be called because of the AUSD. So buy AUSD. New owner ID. So this is correct. You should call new owner ID or like pass the new owner ID. Contract owner. So we increase the balance, decrease the balance, and save both of them. Sell AUSD. So we decrease and increase. So this is where the issue was, where you like, well, it can just fail because the balance is 0. Okay, get account. This requires to, no, it just creates a new account and refund storage. So that's it for this implementation. So what I would suggest is upgrade to the latest fungible token. There's probably going to be some mess with the storage registration. Then you need to rely on the callbacks. So remove all the allowances from here because they're not needed. Oh, there is burn to unstake, but do we really call it? Oh yeah, we do call it. Okay. Yeah. So yeah, to all methods, you need to pass the account ID. So all methods that you mint in. So mint2, account ID, amount, burn 2 on stake, account ID, burn amount, on stake amount, and so on. Sell a USD. Basically, on credit until sold. And so on. Then and finally ratio overflows. I'm not sure if it's correctly handles overflow or not, but maybe it does. Matt, do you have any question?
Not really. It just seems like, well, I mean, I'd like to sort of understand a little bit about simulation, or not simulation tests, but simulation out in the real world. Well, I guess like a Monte Carlo or something, to see how this actually works.
Mm-hmm. Yeah, I guess the main problem I see is like there's really no need for art token in terms of like to make it stable. So it sounds like MakerDAO mechanics where you over collateral. Well, not really, because you. So I'm not sure about the stability of the art, because you can buy art with near, but then the contract doesn't have any selling. So you kind of stuck there. If you have a USD, you cannot claim near, or so near is like one way. You can like basically, yeah. So there is no way out of art or AUSD to near, so that's why there's no stability from the other side, unless we looked somewhere and there was one. So there's only a market that does this. Then interestingly, the way callbacks are implemented are, you kind of rely on other contract calling you instead of you scheduling the callback. And the problem here is the other contract might not have enough gas to schedule this callback, so your callback will not get executed. So you may get into invalid state. All right, so that's it. I'm not gonna run the simulation completely. So there are simulation tests, which is kind of cool. Matt, any questions before we close this?
No, that's it for me.
All right, cool. Thanks everyone, and see you next time.